Hi, everybody. I just want to pop on quick and talk a little bit about radar and how we use radar in the forecasting of tornadic severe weather. So let me actually come over here to what we call our composite loop. So radar, when the radar signal goes out from the tower, it scans at different angles, right? Starting at about half a degree and then all the way up to almost directly overhead, but not quite, so like 89 or something degrees, right? So we're scanning all these different layers of the atmosphere. So we can see from what we call the base, to be our lowest angle, all the way up into the cloud, right? And as we go away from the tower, right, we can see higher and higher, right, into the storm. So that signal goes out from the radar tower, it hits an object, in this case, hail or a precipitation droplet, and then returns to the radar signal. And so from that return, we get a value in what we call dBz, which is decibels of Z. And then from that, we infer intensity of precipitation, right? So when we look at a radar like we're looking at right now, the reds are more intense precipitation, hail, heavy rain, right? Things like that. One of the classic signatures we see for a tornado would be a hook echo. Not really easy to see here in this particular image. So what I want to show you is the other way that we can try to find rotation in a storm system. So if I go to velocity, right, storm relative loop, okay, this is the direction the wind is going. So if we look close to Binghamton right now, okay, you'll see red and green values, right? So typically, right, throughout the whole kind of general region, wind is moving at one direction. So the reds would be going towards the radar tower and the greens away from the radar tower. So that's the general kind of path of the wind. On a case like today, where we have possible tornadic activity, we actually see what we call a couplet. So right here in this red box, that's where there is a tornado warning right now near Oneonta and Delhi area. And so this couplet, this joining of red and green in almost a circular shape, if you were to zoom in on that, tells us that there is rotation in the cloud, right? Because we have winds that are moving both towards and away from the radar tower in this region. So Doppler radar has really helped us be able to see into the cloud and into the storm. So often before a tornado even touches ground, this gives us just a little bit more warning time so that we can warn the public, protect life and property, right? Try to get people out of harm's way. So this tornado warning is because either we've actually spotted a tornado, or more likely than not, because we see this couplet, right? We see this circulation on this relative velocity image, okay? Your book talks about this a little bit more in the satellites chapter, in the chapter on remote sensing and how we use both radar and satellites and other instrumentation that doesn't have to be, right? It's remote. It doesn't have to be in the spot that's occurring, right? We didn't need an instrument or a person even on the ground where this potential tornadic rotation is. But from radar, we can get that information out to the public really fast.